The main thing electrostatically charged nanoplastics do is they destroy the mitochondria inside our cells. The heart is one of the body's most energy-demanding organs, and it's the mitochondria, the energy producers, that give it the power for every single beat. And when mitochondria start to malfunction, the heart literally stalls. It no longer has enough energy to maintain a normal rhythm or strong contractions. Heart attacks and strokes remain the world's leading causes of death among all diseases. In this context, it's especially alarming that scientists have found micro and nanoplastics inside atherosclerotic plaques, dense deposits within arterial walls that narrow the vessels and can obstruct blood flow. When a vessel becomes constricted or a clot forms, blood circulation to the heart or brain is disrupted, sharply increasing the risk of a heart attack or stroke. Research shows that when microplastics are present in carotid artery plaques, the risk of these life-threatening events and fatal outcomes rises by 4.5 times. Micro and nanoplastic particles trigger blood clot formation. When micro and nanoplastics enter the bloodstream, they don't simply drift there passively. Because of their electrostatic charge, plastic particles stick to vessel walls and attract blood proteins and cells. These coated particles damage the endothelium, the ultra-thin layer of cells lining the inside of blood vessels. The endothelium is like an intelligent shell of the vessels. It regulates their dilation and constriction, controls blood clotting, and protects against inflammation. However, under the influence of micro and nanoplastics, this system breaks down, leading to chronic inflammation and an increased risk of thrombosis. In addition, electrostatically charged microplastics can interact with blood cells, platelets, and red blood cells, disrupting their normal behavior. Under normal conditions, red blood cells carry a negative surface charge called the zeta potential, which keeps them from sticking together and allows blood to flow freely, even through the tiniest capillaries. But when exposed to microplastics, this charge decreases. Red blood cells begin to clump together, blood viscosity rises, and clot formation starts. As a result, clots appear in the vessels, obstructing blood flow, which is especially dangerous for the brain, heart, and eyes. This consequently increases the risk of chronic fatigue, vision disorders, hypertension, heart attack, and stroke.